Hello all, I'm Hilary, the User Experience Research Lead for Google Fonts team. With me today is my colleague in Google Fonts, Dave Crossland. Also here is Michael Gilbert, the User Experience Researcher who led the research design and conducted our first experiment. We will introduce variable fonts as a technology for typography, describing how we defined and measure the readability of texts produced using typographic variations. Reading dark text on a light background is called light mode. By contrast, reading light text on a dark background is called dark mode, also known as the reverse polarity. Most smartphones and computers have dark mode and light mode settings. People can choose what they would prefer to have as their main setting. The mode they choose may influence readability of their text. We're going to describe two research experiments where collectively 459 people were timed successfully reading different typographical presentations of a variable font called robotoflex.
Robotoflex is a new typeface design which I've commissioned from one of the best font development companies in the world, Font Bureau. The founder, David Burlow, and his team took the original Roboto design from 10 years ago and they redrew it as an exciting new design, which takes full advantage of the new variable fonts technology. It is a single font file which contains all the styles of the typeface family because it has axes of variation which can be combined. Here we see Robotoflex varying in weight, and you see the Figma design app has a font settings panel with sliders for each of the axes of variation. So instead of a set of 2, 4, 5, 9 separate styles, from extra light through regular semi-bold to extra bold, there's a smooth, continuous range for weight, which you can customize. Something special in Robotoflex is another axis called grade. And here you can see that as the grade changes, the visual font weight appears to change too. But unlike the weight axis, there are no changes in the line length or paragraph layout. So what's special about these grade styles is that they all have the same layout metrics. So line breaks and whole paragraphs do not change as you change between different grade styles. Today with digital media, digital designers like to use grade for hover effects on things like buttons, where the reflow from a weight change would be undesirable, and to adjust text between light mode and dark mode without affecting any text layout, which is sort of similar to the two different magazine paper types.
So with that in mind, the specific question we wanted to answer with this research was, does the grade font characteristic need to be different in light mode versus dark mode to ensure an equivalent reading experience across both modes? In this first experiment, we looked at glanceable reading. This type of reading is what you might normally do when you glance at a location, to quickly read something with minimal effort. In a UI, that might include reading things like menu items or button labels or headings and titles. Considering the participant experience for this study, each participant was asked to read a series of 2-word phrases as quickly as they could, and then to retype those phrases from memory. The phrases were randomly selected combinations of 2- and 3-syllable words, and we controlled for word familiarity by selecting from the Dale-Chall word list, which aims to ensure that 80% of 4th graders are familiar with the words. Ultimately, each participant was asked 5 questions for each of 5 grades in both light and dark mode, plus 3 training questions before each of the modes, so 56 trials total per participant. After collecting and cleaning the data, we had over 4,800 trials from 126 participants, and we can explain all the results pretty much in one graph, which is shown right here. What we're seeing here is a graph showing reading speed in words per second on the y-axis, with the grades evaluated on the x-axis. And here, the top line shows the light mode results, and the bottom line shows the dark mode results. Now, there are 3 main takeaways from this graph. First, at the highest values of grade, light mode was more readable than dark mode. Second, in dark mode, readability doesn't vary significantly at any value of grade. And third, readability does vary significantly between light mode and dark mode at higher grade values, at least above the grade value of 62 in this data. So increasing grade can improve glanceable reading speed, but potentially only in light mode. And at the default grade value, there's no significant difference in reading speed between light mode and dark mode. So at least for glanceable reading, it looks like no changes to grade are necessary to support equivalent reading experiences across light mode and dark mode, which answers one of the primary questions we had motivating this research.
In this second experiment, I've copied the research design so that we can compare glanceable reading and reading paragraphs. I've used the material design system body text settings and taken a closer look at grade levels over 60 by adding a measure at the grade level of 100. We used 2 paragraphs, each just over 100 words long. Each paragraph was shown to our readers in both dark and light mode. We counterbalanced the presentation order and polarity across participants. Every one of our 333 participants read in both the light and dark mode at 1 grade level, then successfully answered questions about paragraph content, demonstrating that they'd actually read the content. We also asked our readers what their current phone displays and their preference for either light or dark mode. What you're seeing in this graph is the fluency in words per second for reading the paragraph and successfully answering the questions. The higher line is reading fluency for the light mode, and on the lower line is reading fluency for the dark mode. There is a main effect of mode on reading fluency. We did not detect an effect of grade. We tracked and saw expected effects like a decrease in fluency with age. And when people are interested in the topic of the paragraph, they read more slowly. We did not see a significant impact of grade for paragraph reading. For the settings we used, manipulating grade made no detectable impact on reading fluency. As well as measuring reading fluency in words per second, we asked the paragraph reader about their experience. What mode are their phones typically set in? About a third normally use dark mode, and a third normally use light mode. The remaining third switch between the modes or do not know how their phone normally displays the text. How did they prefer reading the paragraphs that they had just read in the study? A third preferred reading light mode, a third dark mode, and 1/3 had no preference. Which paragraph did they think was visually clearer? More than a third felt one mode was clearer, dark or light. Opinions about visual clarity do not map to reading preferences or performance. There's no dominant preference for the use of light mode, despite the clear fluency advantage they demonstrate during the experiments. In summary, these 2 studies, with a total of 459 participants, we examined the effect of varying grade levels on both glancing and paragraph reading activities in light and dark modes. With the settings used for our studies, we found that dark text on a light background, light mode, is more readable, but not considered more visually clear or preferred by a majority of people. We did not find an effect of grade for paragraph reading, and we found an effect for the higher levels of grade for glanceable reading on computers. Using the material design settings, designers can use grade for typographical effects without concern for the notable adverse impact on readability. Grade can be used for reasons outside of enabling consistency across different technologies and body text reflow. Grade could be used to emphasize the location of the cursor on the screen without causing reflow. There is room to explore possibilities without having a negative effect on reading fluency. We look forward to discovering how different variable font manipulations will facilitate reading fluency and engagement in future research studies.